Okay, so module number 15 that we are talking about vSAN storage architecture. Okay. So here we are going to talk a lot about the storage ESA, and that's we refer as vSAN Express storage architecture and a next generation storage solution. So what I thought of, if you people know a little bit about the Nutanix HCI framework or the Nutanix HCI system. So I believe they follow the same thing here, and they just do a lot of scalability and breach the barriers what we were thinking in the OSA. Kind of just one moment, guys. Here is a huge light cut actually. So it's 3-4 hours now. So I was assuming it is back, but no. Okay, so let me come back on the point. So what I was telling is, like with ESA, they have broken a lot of barriers that we were seeing in the OSA that we call as an old storage architecture that we all covering here. Talk about the vSAN ESA, then vSAN ESA storage policies around that. So the first lesson where we are covering the overall, like this is the overall objective, describe the vSAN ESA, enterprise vSAN, understand the ESA device storage configuration, then the vSAN snapshot, that comes pretty new feature here, and understand the ESA encryption. Okay, so if we start from the lesson one, what is the vSAN Express storage architecture? So vSAN Express, like the way till now we are seeing, like vSAN have made lot of enhancement, like from 5.5 U1 onwards, they have introduced the hybrid model. Then dual tier capacity was there. Dual tier is still available, like cache different and capacity different. Then people raise a lot of question why I need to waste a lot of amount around the cache, right? Then from 6.x onwards, they have done an enhancement. They bring up the all flash model. Still the hybrid model was there. When we say all flash model, there we're talking about like my cache is SSD and also my capacity is my flash drive. Then from vSphere 8 onwards, they have started the express storage architecture. On a high level, they are now saying the single tier model, no separate capacity or cache drive. That would be a single tier. But end of the day, all my drive would be the flash drive. Okay. So single tier means is you don't need to configure separately cache and separately capacity. There would be a single pool of all the underlying physical disk that we are leveraging from the ESXi hosts. Okay. And still it is a native inbuilt feature like as vSAN, and also we'll going to configure from the same console. Only we have to do the election. I mean, say the right election of storage type. Either we are going with OSA or we are going with ESA. Okay, we good so far? Yes, no?
Yes, sir.
All right. My voice is clear, right?
Yes,
Yes, sir. Yes, sir. All clear, sir.
Okay.
yes, sure, voice is clear.
Yeah, fine. Thank you. Well, here is some differentiators being shown here in this slide. Well, we'll say the old storage architecture, they will supporting the hybrid and all flash, but now it's purely all flash, no hybrid model. Storage configuration, two-tier disk construct known as an disk groups. So single tier structure called as an entire storage pool. Disk's maximum configuration, where we're talking about the total disk, like 5 disk group, and out of that 35 capacity, then total it goes to 5 plus 35, total 40 disk. Out of 40 disk, like 5 were in cache and rest 35 for capacity. You remember that in each disk group we talk about maximum 7 disk group and maximum 5 disk group we can create per host. So here, so scalable architecture, there is no limit. It's all depend upon your hardware configuration. You can bring up to the limit you are requiring for. Okay. So now this number of disk limits is finished. Compression is by default off. However, you can enable that, but in vSAN ESA, it is on by default. Compression scope, cluster-wide setting, but here, if you want to make a compression on specific object level, you can go and you can select. For encryption purpose, 1 KEK source is required, and per cluster, 1 disk, we required a disk encryption key separately for that. Here, 1 KEK per cluster and 1 DEK. I mean, you don't need to create the separate DEK. Probably you remember our last discussion we have shown,
Yes,
like
sir.
we
KEK
require
and DEK.
separate DEK per disk, right? But here DEK is per cluster. Okay. Version, supported version is still with vSphere 8. We have the OSA, but ESA will get only from 8.x onwards, right? So these are the main difference. If someone will ask you like during the interview, like what are the key enhancements being done in vSAN ESA? However, they just missed a few points here that we are going to discuss specifically to storage policy itself. They have made certain enhancement, like for example, like earlier with the Razor coding grade 5, we have the foundation 3+1, but now you can go with the 2+1, 3+1, 4+1, any kind of architecture for more space optimization. So primarily when we are thought of like we want to build an ESA cluster, what actually we need for that? So definitely we need some high end of configuration as compared to OSA. So my node should be vSAN ready node as per my HCL hardware compatibility list. Minimum CPU requirement is 32. Then minimum RAM to be on host should be 512 GB of RAM and 25 GB dedicated NIC for the vSAN traffic. 1 GB NIC separately, that's for your VM management and all. And minimum of 4 NVMe SSDs per host with the endurance of class D or better class F. These are the disk endurance, like when you do selection of the physical disk, and disks at least of 1.6 TB in this size. Okay. So the target of bring up ESA just to directly comparison with the enterprise level of storage. Okay. So that's why they have made a little bit higher requirement, a little bit more expectation, like when a customer is looking for the ESA solution. Correct? Then, as I said, like supported deployment, what we can do with the ESA itself. So we can do a standard vSAN cluster, a 2-node cluster, a vSAN stretched cluster. All the configuration is possible with the ESA architecture, right? So before this wizard, you will be before this, you'll be getting one more wizard where you will select either OSA or either ESA. Okay. So from there, we have to select. Okay. So still I can go with the kind of remote HCI mesh kind of configuration if I don't want to use within ESA architecture. I mean, in a simple word, I would say HCI mesh is supported with the ESA as well, along with OSA architecture, right? Then this is the one where we were talking about the ESA cluster. You will just, when you will go for the cluster election, you will select enable vSAN ESA, right? The bottom tab, it's moreover just to looking for the common host images from single image you are using all the host. You can elect, or it's an optional thing for you. If you want to continue with that, you can select. If you don't want, then you can keep it in a default option, unchecked option, right? So simply like when you will enable the ESA and all, how you'll get to know, like you are new person enter in a project, and I'll get to know like, sir, I'm using OSA or ESA. So simply when you will go with the services, then you will type storage type here. Instead of OSA, you will find the ESA. And also you will get a command from any of the host, ESXi, vSAN, cluster get. And here you will see vSAN ESA enable true. Okay, it means that you are using the vSAN enterprise storage, express storage architecture, right? Then if we'll see the disk comparison again with OSA and ESA, then definitely within disk group, there was one cache was mandatory to making a particular disk group. But here it's simple, like you don't need to create the separate disk group. Only you are going to claim your disk directly. And yeah, definitely cache will be reside somewhere, but it's not like that a dedicated cache for that. Reason is being because I'm using all flash here for both, so get better performance and better things. So some of the percentage it's definitely using in the backend, but you don't need to separately indicate that kind of here. This is moreover similar to, I would say, again, I would repeat my word, if you little bit study on the Nutanix HCI environment, where they don't have this concept, they only using this concept kind of the complete pool, which is maintaining the cache and capacity, right? So how it's happened, like sir, do we need to still maintain the cache kind of earlier architecture where my cache drive is primarily maintaining the right cache? But here it's direct. There is no separate cache maintained. It's direct. VM is directly reading the data from underlying disk. It's not coming through kind of cache, or VMs are directly writing the data in any of the disk, right? So it's single tier architecture, only support all of flash. Okay, but it's not hybrid, right? Keep in mind, it's always all flash. Pool of independent storage device, reduced IO, definitely. Then number of disks slot define the maximum number of disks can be supported in the particular host. So do we have any limit of maximum disks here? Do we have any limit of maximum disks here? Yes, no?
No, sir, no.
So we have in 7.0, sir. In 8.0, we don't have.
Right? So here we have scalable architecture. This kind of architecture we refer as the scalable architecture, right? I mean, there is no limit at all. No flash, and vSAN is ESA compatible. Then total claim disk here we could see the 100%. It means that the number of disk what is there. So now you can see here is no separation of cache and capacity, right? Earlier, when we were seeing in the OSA, the disk group, there was showing this disk claim as cache and capacity, right? But at this point, we have to keep in mind all the disks size, those are participating, should be equal. Okay. So from here, change the claim mode. So when enable, vSAN will claim all the compatible disk automatically. Disk will be claimed by vSAN. Any manual added disk to be existing host are not affected by the setting, can be manually claimed. Manually claim means is like if you are kind of scaling up your nodes with additional disk, then you have to claim. Definitely they will show as an unused or unclaimed disk. Then you go ahead and you can claim. So here it will show you kind of the disk device ID, vSAN storage pool list is this particular host, right? How many disks I am using it, and what are the device ID being configured for that particular disk, and what is the status. Okay, so IO flow, vSAN introduced JDOM and LSOM architecture. So sits on the top of DOM owner, then replace this was the known previous one architecture for distributing the data. So whenever my data is written by the VM, it's received, it's an internal component of vSAN, right? Then DOM client take it, Then ZDOM is the DOM owner and DOM component manager. This is what is locally, writing the data inside my flash drives. So, I mean, somewhere I'm getting the faster data read and write as compared to the previous architecture. So, review of vSAN snapshot. vSAN 6.0 introduced the vSAN sparse snapshot, which is function as a redo logs. When we say redo logs, it means that it's simple thing like my base disk and whatever the delta, whatever snapshot disk will come, that will be defined as the entire kind of delta disk on the top of parent disk. And when we are, when we are taking another kind of snapshot, it would be a more kind of delta. Okay, but how my data will return? Simply, when we take the snapshot, my delta will be always go inside the delta disk, and once I'll delete, it will go in a parent one, the previous one, and once we'll delete kind of all snapshot, they will be merged into my parent disk, right? It's the native concept. So like a snapshot is supported altogether within the vSAN. So here they have done a little bit in different way as compared to the traditional we are using in the vSAN. What kind of enhancement they have done? So it's kind of using B positive tree logical map to point to different blocks of data storage in vSAN to assemble a snapshot. So how it will work actually? So when an administrator create a snapshot, vSAN ESA create a logical map. The logical map stores on the location of blocks of data that make up a snapshot. So it's a kind of, it is not purely defined as an delta disk. This is defined being as an kind of logical map. Okay, so when we say the logical map, so if you will see the blocks here, like this one example, here is the block from 1 to 16. So whenever our data will be written into logical map 1, let us suppose the delta changes being happen only here, okay, on that particular block. So when you delete it, it will be kind of merge 1 to 1, 3 to 3, and 6 to 6. Why it is like that? Why not 1 to 3, 4, 5, 6? Reason is being here, it is being considered as kind of the changes being happen. The changing being happen in the logical map 1 only on these blocks 1, 3, 6, 7, 8, 16, 15. This is just a random number. Okay, just for example they have taken. So if I compare it with the previous architecture where we'll say the delta VMDK. So merging of delta VM, always when I delete the snapshot, merging of delta VMDK could take some time because you have to find the existing block just to merge the data on the right place, okay, where my data should be, merged on the particular parent block. So it always took some time. But if I will say, yeah, definitely this is a delta, but the change is being captured on the particular parent block. So it identified like this change will happen block 2, this will change happen block 6, this change happen block 8, this change happen on block 10, kind of that. Just for an example, this could be 13, this could be 15, any kind. So when we going to delete the snapshot, this logical map 1, like from VM, definitely it's a snapshot. So it will immediately identify where is my parent block. Okay, where is my parent block, so that whenever you delete the snapshot, it is bit faster merger, right? And the optimization as well. Clear on it?
Yes, sir. Yeah.
Yeah, cool. So same way, the benefit of little to no performance degradation. Maps are only logical, stored in the VMDK object. Better snapshot scalability. Max up to 32. However, earlier this limit was 32 itself. Snapshot managed on particular object basis. What it means? it only detect the only object where changes being happened, right? And no user visibility functionality change, like user will not feel that, and nothing new object will not created at all. So it will automatically what it will do, like this is my parent object one here, this create, like when data will come, it will create a logical map on the top of one only. If data changes will happen on three, it will happen only on three object, and it will give me a little bit faster whenever I'm going to delete the snapshot and I'm merging the, definitely when we'll do the delete, it's a merge. Okay. Now let's talk about efficiency. Again, like when we say earlier, the compression architecture was like that. First, my data land up to the cache drive. When it is going to writing the data, the compression engine works here. Okay. And then my data compressed to my underlying capacity drive. But here, because now there is no cache tier at all, so my data directly go through compression engine to my SSD drive. Okay. So definitely it's giving me the better performance as compared to OSA. Second is you can configure compression on per object basis as well. What does it means? Per object means is I can select particular, like once I enable it. Okay, so here this is my VM storage policy, and storage policy I am making an kind of storage rule. Okay, so here I'm not enabling their data storage efficiency itself. I'm selecting this, and I'm selecting this compression only. So now this will, here it will, just one moment, let me go back. So what it mean is compression only. So like particular dot vmdk file, I can enable, this is the level of granularity I can enable for the particular object, kind of a VM folder, kind of a snapshot, kind of swap file. So I can enable the compression on that particular object level as well, instead of the entire vSAN data store. So next is encryption. So here vSAN data at rest securely encrypt the vSAN using AES before it lands on persistent, means your permanent storage. Leveraging vSAN encryption, providing the features, decide on the disk is encrypted. No need for self-encryption drive. FIPS, this is the my encryption standard 140-2. Support the KMS. I mean, support both the features, kind of native key provider or external KMS. Cluster-wide setting for all the object, and vSAN ESA applies per object-based setting. My love, it's encrypting each of the object I am writing, where inside this OSA architecture, it was applied on disk level. But now, whatever the object I am writing, the data is being encrypted. Okay, specific object level. So from enabling perspective, it's simple way, like we have to enable it data at rest encryption. The key provider could be my native key provider or my external KMS that is supported. Okay, like enabling the feature supportability of KMS is almost same, but it is a little bit granular inside the component and object level. So it is just applied per object instead of the entire disk that was in OSA, right? Okay, so the same way you have to enable the functionality of encryption and all. So what is the difference here? Because earlier architecture, if you compare the previous OSA and ESA, what difference you have seen here? Any difference you see?
There we see each disk wise, but here only cluster wise you can see KE, KD.
Yeah, KEK definitely it's per cluster, right?
Yes, sir.
Okay, so this will get from the host, but now there is no separate DEK
D.
because earlier for each disk, you remember that there was a separate data encryption
D.
key, right?
Yes, sir.
But now a common DEK advantage of it is like performance enhancement. You don't need to generate the separate DEK for each disk. A common DEK is just encrypting the entire set of disks are available on the underlying host, right? So definitely we sent a request to generate a key encryption key and a DEK. We sent a wraps the DEK with KEK and pushes to the CMMDDS faster. This is my published CMDDS master node. One of the node will become master and rest of the node will be getting those DEKs from the master node. Host request the KEK from the KMS server to unwrap these DEK keys, which is being shared vCenter to master and master to another nodes. And objects got encrypted based on the configuration storage policies, right?
So it's like same host, master agent, and slave, like HA also.
Sorry, Sarvan, can you come back?
No, this is like we have a master and slave in SQL host, right? When we
Yeah,
trigger
master
HA.
host will be getting these DEK first.
DK.
Okay. Then for encrypting, for applying the DEK, a host is individually calling to my KMS server just to receive the KEK. KEK is for encrypting the DEK, right?
Yes, sir.
And DEK further, a common set of DEK will be applying to all the underlying disks for encrypting your data. And data is what? It's apply on not only on disk level, it is applying on the object level. It's encrypting the data at rest encryption is happening on object level, right?
Yes, sir.
Okay, so this is again the mechanism how it's happened. The guest OS send write data, then JDOM compress the data, and JDOM encrypt the JDOM component, perform the compression and encryption happen before data lands onto the disk. And LSOM is the final component like which will be writing the data on your underlying disk. But the responsibility of applying this compression and dedo by your ZDOM component, right? So storage policy rule, you can create a storage policy or you can update any existing storage policy, including the data at rest encryption. Any object with this policy applied are encrypted. Definitely, if you will enable, then it will because you have enabled the encryption service data at rest encryption, right? So what it's telling you when you are creating any kind of storage policy within or you can update any existing storage policy there also you can enable the data at rest encryption. So here is a quick lab where we'll see like how do we build the ESA, create the cluster, configure ESA cluster, and just to check the cluster setup by using the ESXCLI command. Yeah, definitely that will be going to cover in the lab itself. So making cluster and all, if you'll ask me like, can we create a nested environment? That's absolutely possible. Only we have to just take the equal size of disk and also like we have to publish them as an all flash. Then yeah, this is the one. And this is what we have discussed here. ESA architecture, device configuration, how snapshot get different and how compression and encryption works in the ESA, right? That's what we have covered. And the next lesson is the supported storage policy, then identifying the differences in the storage policy.
Okay, sir.
All right.
Okay, sir.
Yes,
Yep.
sir.
Yep.
We good to continue or just a quick 5 minutes break? Will that be fine?
Yeah, we can take breaks of 5 minutes, 5-10 minute break.
Yeah, yeah. So
Thank you.
that you can easily, absorb these are, little bit new terms here and new tech concept and technologies. Yeah, I'll be starting next as in about the storage policy, how storage policy is different than the OSA, right?
Sure, sir.
Okay,
Okay.
sir.
Yeah, so I'm pausing the recording for now and I'll start from the same place. Okay.
Yes, sir. Okay.
Yeah.
We'll
Let's
catch
see.
you in 5 minutes, sir. 10 minutes, sir.
Well, this lesson is moreover focused on supported storage policies and storage policy differences as compared to OSA again. Okay, so while using vSAN ESA, it supports again RAID 0, RAID 1, RAID 5, RAID 6. The write operation behavior is a bit different. In ESA, experience the following behavior. The ESA perform full data strip write. 128 KB per data component. Okay. In one write, 128 KB. Each object has perf performance and a capacity lag. Okay. All writes are received on the performance lag. When a full strip of write accumulate, it committed to the capacity lag. Means once it will receive the entire 128 KB of data. So it go in that way. P and C. Write load on the performance lag first. After full strip is received, push this P to C. End of the day, the entire data strip is available here. So this improves the write IO performance by not having the partial writes. The entire strip of data, that is my 128 KB. Okay, so the performance and capacity lags are used for write data within vSAN ESA environment and having the following child component depending upon the RAID type. When we say the child components means is how many, it will split in how many components. Like for an example, N+1 failure to tolerate +1, then RAID 0, FTT 0. It's always have one child component only. RAID 1, FTT 1 will have two child component because one is for redundancy. RAID 5, FTT 1, two child. RAID 6, FTT 2, three child. Three child means is one parent component plus rest is child component, right? Then capacity lag 1 to 2 child component, especially for that. Then RAID 0, RAID 1. It support RAID 0, RAID 1 to 3. RAID 1 have three child component, RAID 5 or RAID 6 have the two child component in the capacity lag. So let us understand in bit detail here. So the capacity lag component perform the following process with the OSA architecture environment. Administrator initially deploy kind of 100 GB of VMD and later decided to expand it to 300 GB. A new concatenation we say concat in short form. Component is deployed to temporarily satisfy the request. A resync is triggered to evenly spread the data across new dataset component. Once resync is finished, the original component plus concat component is deleted. It means that it get merged with the parent component. Okay. It is kind of when we do the kind of expansion. Like earlier it was 200 GB, then later it decided to expand 3. It means the plus 200 GB data came in. Then concat component is deployed temporarily, satisfying the requirement. It means that until unless it will not, occupy all three, I mean, it will not consume or it will not had this space like 100 GB plus 200 GB. By default, the default nature was is here like C1, C2, and the witness component. Okay. Then concat are temporary state. Temporary state means just an additional state, and later on it will get kind of merge like C1.1, 1.2, C2.1, 2.2, kind of that of each component's delta. Then it will get merged in the kind of my parent. Parent means like this for temporary, this is C1.1. Then later on it will become entire C1. It will become entire kind of C2. Same way here, C1, sorry, C1 and C2. Then capacity like component, capacity is my main one. I mean, main is finally it will go, my data is going to write into the capacity tier. So if in vSAN ESA, if an administrator expanded VMDK from 100 GB to 300 GB, no new component would need it to be created temporarily. Each component size by default is 255 GB. In both, yeah, definitely that's true. This each component size is 255 GB. And vSAN ESA over provision address space by 3 times for RAID 1, 2 times of RAID 5 and RAID 6 that we are using. So simple example, like if an administrator deploy a 40 TB VMDK with RAID 1 storage policy, vSAN would provision the enough address space component to support the additional 120 TB. Why it's saying 120 TB? Because if let's for an example, if I'll apply kind of currently how much space is here? 40. 40 is the original disk size.
40 TB.
40 is my original disk size, okay, with the RAID 1 policy. So vSAN would provision enough address space for the rest of the component to support, like this component don't need to kind of, whenever I'll do kind of expansion, this C1 already have the expansion capacity because my one component size can go up to how much?
255 GB.
255 GB. So that's why it is saying if I am increasing my disk like 40 to 140 TB kind of that, and now you'll say it is 40 GB. That's right, because this 40 TB is further split it into rest of the component. Okay. So I mean to say that this C1 don't need to create kind of C1.1, 1.2, 1.3 kind of
Child
additional
components.
component. Same way, it doesn't need to create 2.1, 2.2, 2.3 as an additional, then get and resync and make it rebuilt again. My existing component itself having the capacity just to tolerate, I mean, just to manage the additional expansion. Okay. So now you'll say, sir, you are telling me disk level, but it's component level. Definitely, my 40 TB could not be one component. This 40 will be further divided into kind of components, C1, C2, C3, and kind of that. But these components itself have the initial buffer, so they can tolerate like whenever I'm going to increase my disk. Okay. So this is something internally. You don't need to be worried too much about that. This is something being taken care. But yeah, definitely these kind of mechanism just enhance the performance, right? So here, when we apply the policy, kind of RAID 0, FTT 0 RAID policy. So per flow, then C1 from the top level, it will show you C1. But internally, you will say it have split it into 3 component, right? And within RAID 0, definitely it is not providing the redundancy because this is not kind of C1 copy of C1, C2 copy of, not like that. This C1 is itself split into 3 component. This is whatever RAID we will apply by default, my address space by 3 times. Means earlier it was kind of C1, C2, C3. Now this C1 itself placed on 3 places. That's what he's trying to say here, right?
Yes, sir. Earlier we have 1.2, 1.1. Though here we
1.
don't see the child components.
1.2, 1.3 is for expansion actually. So
Okay.
see, let me take one example here. If I am taking with OSA FTT1 RAID 1, I will write the data in FTT1 RAID 1. C1, C2, witness. Correct?
Yes, witness. Okay,
That's
sir.
your way of writing data. But now here, this C1 itself further split on
Divided.
3
Okay,
places.
okay.
But
Okay.
again, don't see it's a redundancy. It is not a redundancy, right? It is just a split, just a shared
Split.
of the
Okay,
C1 only. There is no redundancy between them. If let's for an example, just for example, this is 15 MB data, 5, 5, 5.
5,
Kind
5.
of that. But these
Internally
5 are
it
separate.
will divide. Okay, okay, okay.
Same way this C2 is on 3 places. That's what he's trying to say.
Okay, sir. Got it, sir.
Your
Okay.
capacity lag further divided into 3 component and sitting in
Components.
3 different
3 in hosts. Okay.
Okay. So
Yes, sir. Got it.
now if we compare here, when I will come to RAID 1 FTT1, definitely my 2 components will go. This is my per flag. Per flag means initially it will write the data. Okay. Per flag, see, what is it? It is just parallel to your cache. But earlier your cache drive was separate, but now my cache is maintaining in my performance kind of lag. Okay. So kind of per flag is the my hot tier data, I would say, right? Hot tier data is means what I am accessing frequently, reading, that will go, frequently writing. That's a kind of my per flag. So 2 performance lag component, 3 capacity here, because what I did here is RAID 1 FTT2. When we say RAID 1 FTT2, what do you mean by RAID 1 FTT2? What you say? Definitely my 3 components will go. Okay. And RAID 1, try to understand. This is my this policy is for my per flag, means how my per flag, how my data is written in the performance lag. If I'll apply RAID 1 FTT2, what is the default nature of RAID 1 FTT2? What was the default nature of RAID 1 FTT2? Data, original data
Yes, sir.
plus 2 mirror copy.
Yes, sir.
That was right. So then total how
Yes,
many
sir.
component? 3.
3, sir.
And RAID 1 FTT2, if I'll apply the policy RAID 1 FTT2, what will happen? 4 per flag, definitely, because 1 original data plus 3 mirror copy. Then total was 4.
4.
Correct? But now,
Yes, sir.
what policy is here? RAID 1,
1 FTT1.
FTT1 for both, because it's a common, right? It is the common RAID 1, FTT1. So when I say RAID 1, FTT1, how many component will create? In RAID 1, FTT1, what I thought of? 1 my original plus 1 mirror.
1. Yes,
There
sir.
should be 2.
2.
So if I'll come here in per flag, how many? 1,
2 are there.
because 1 is original plus 1 is mirror copy.
Mirror copy. Yes, sir.
Now if I'm talking about the capacity, in the
Capacity.
capacity, how many? Again, the policy is same. 1 original data
1 mirror,
plus
1 mirror copy.
mirror copy. So how many here? C1 plus
C2.
C2. Okay.
2.
Correct. But now
Yes,
you
sir.
will say, sir, why these 3C here? because within underline, this will further divide it into the three.
Three components. Yes,
Right?
sir. Got it. Got
My
it, sir.
underline component will be further split into three component. The one which we are talking here, RAID 0, FTT 0. However, my original component is 1, but it will be placed on
Three places, three
three
components.
different places, right? Three sub-component, or I would say three child component. These are my
Components.
child component, right?
Yes, sir.
If I'll go a little bit back here,
Here, one component. Yeah, right.
RAID 0,
Yes, sir.
FTT 0,
One component.
right? RAID 1, FTT 1,
Two component means one
RAID
mirror,
5.
one parent.
Yeah. So again, it's depend like how I have applied my policy, what kind of policy I am applying. Okay.
Yes, sir. FTT2.
So, Banu, are we clear?
Yes, sir. I'm little bit lagging, but yeah.
Okay. Okay. So see, on the top, policy is almost same, but only the difference is the underlying data I am writing here. This, see, till now, this C1, C2, that definitely this is my RAID 1 FTT1 policy, right? What is RAID 1 FTT1 say? One original data plus one mirror copy, correct? But underlying this C1 is going to further spread across three nodes. Okay. But again, as I said, there is no redundancy between them. The redundancy between C1 and C2. It means that the redundancy is between this and this. Or I would say this and this, C1 and C2.
Sir, if you have four component, it will go into 4C, sir. C1 means C. It will split across into
No.
four nodes.
See, what I... Yeah, see, by default, the nature of RAID 0 will be
Yes, sir.
spread three
Means
places. That's the
sending of
nature.
data.
You
Yes, sir.
cannot go
Yes, sir.
four at all.
Okay.
Okay, this is the default policy writing mechanism here. You will not go beyond three.
Okay, sir. Okay, sir.
Okay.
Yes, sir. Got it.
Now, if you will say, sir, then if there is C1 is on 3 place, why perflog is on 2 place? You can ask. Still policy is same. Reason
Yes,
is
sir. Yes, sir.
being what policy said here. RAID 1 FTT1, 2 child component for
Correct.
performance lag.
Yes, sir.
Capacity lag, RAID 0 or RAID 3 have 3 child
component.
component. RAID 5 and RAID 6 in capacity lag have
Only two components.
two child component. Two child component is what was my original component that will be
CC.
further split into two child component. Okay.
CC. Okay.
So
Got
this
it,
I
sir.
would say the parent and this I would say the CC child component. Correct. Same way per flow will have the RAID 5 FTT1. Still it will have two child component only. But here with RAID 5, the two, I mean, for my capacity lag, two child component will get created. So again, I say like the policy definition is different here as compared to we do. So now we can take the another example.
RAID 5.
RAID 5 FTT1 storage layout. So RAID 5 FTT1 storage layout, the first thing is here is we can go with 2+1. That was not earlier. In OSA, when we say RAID 5 FTT1, what was the minimum requirement? 4, correct?
4 disk.
3
Yes,
plus
sir.
1. Data was right in the mechanism 3+1. Data, parity.
Witness.
Parity.
Okay, sorry. Battery. Yes, sir.
Okay. Data, parity, data, kind of that.
Correct,
Okay.
sir.
But here you say, still you can write the RAID 5 FTT1 storage layout. How my component will be split it? Like if it's a 2+1 architecture, it means that it is data, parity,
Parity.
TPD,
Data parity.
TED. I mean, it's a dynamic way, right?
Yes, sir.
Correct. So you can go with 2+1 and right, 3 host you need. RAID 5 FTT1, 4 data plus 1. You can go with this mechanism also, 4+1. You can go with 3+1. That's not a problem at all. Okay.
Okay, sir.
So here this C1, C2, C3. It's writing in that way, right? So note perf lag and cap lag not shown diagram in this diagram. So if I will say, if the cap lag, the capacity lag not shown. So it's a native method. It is just telling you how natively it's write the data. But further, this C1 will go C, C3 will go again C, C. Okay, because it's a native method, it's showing you, it tell you like it is not showing any kind of perf lag and capacity lag here, right? Why I'm saying 2 times? What my policy said?
Two for RAID 5, two childs.
RAID 5 and RAID 6, there would be 2 child components, right?
Yes, sir.
So
Back.
yeah, so RAID 5 FTT1 absolutely minimum and absolutely kind of recommended minimum architecture. What I mean, it's just telling like how many nodes we need, right? So with RAID 5 FTT1 absolutely minimum and recommended minimum in vSAN, and vSAN ESA architecture is in OSA architecture, it was RAID 5 3+1. Absolutely minimum we required there is 4 node, okay? But within this ESA, ensure there is one spare fault domain, means plus host whenever is possible. So ESA RAID 5 4+1 architecture in 4+1, but +1 for reshare means minimum recommended is 5. Minimum recommended is 5, but actual recommended is 6. Why? Because it's writing the data in 4+1 manner, plus it is saying the one host for the spare to maintain the failure. vSAN ESA RAID 5 2+1 is the minimum host. Why it is 2+1? Because it's maintaining kind of data parity, right? +1 is spare. 1 is spare means if any host will get faulty from here, then like if it's maintaining the parity for the time, the parity will be maintained here. Whatever the data, it will be dynamically shrink. Okay. So there is this RAID 5 FTT1 RAID 5 policy change here. 2 manners you can go. Either you can go with the 2+1 architecture minimum recommended +1 for spare. Either you can go 4+1, which is the minimum recommended, but actual recommended is 4+1. Minimum recommended is this 4+1, but +1 for spare for maintaining. However, in both the cases, we are getting one node failure to tolerate, right? Not beyond that one. Correct? We clear? तो इसलिए इन्हें बोला कि recommended minimum is absolute minimum is the 5 here, but the recommendation is 6.
+1 spare.
Yeah,
For safe
minimum
side.
is 3. Simple word you say, minimum is 3,
Yes.
but recommended is 4.
4.
Right?
For hard spare, anything goes wrong also.
Yeah, for maintaining one node as an spare node. Okay.
Yes, sir.
So within
Yes, sir.
here, we cannot go with the OSA kind of thing because ESA we are architecturing. So we can go either 4+1 or 2+1.
Yes, sir.
All right. So adaptive storage layout of RAID 5 FTT1. vSAN ESA has ability to dynamically adjust the storage layout for RAID 5 based on the number of hosts available. vSAN waits 24 hours after adding a new host. Then scale down maintenance mode operation like full data migration when you are doing scale out any node. Operation is when you are doing scale up, operation is lazy efforts, little impact on IO, definitely. But when we do scale down means we are removing any node. Administrator forces a repair an object and not enough, if in case not enough space is available, then a force provision option they have to enable. vSAN avoid changing object layout if change in the policy causes significant increase in the storage. And administrator remove the host from the cluster. I mean, these are kind of how RAID 5 FTT1 works if we are going to add, going to increase, or going to decrease the kind of vSAN cluster with the node where we have applied the RAID 5 FTT1 policy. So again, it's an architecture of distributed parity architecture that we have talked about, like when we are going with RAID 5 FTT 2+1 data parity said, like this is something it will take care. So in 2+1 architecture, how much overload will come? 50%. Okay, how much? 50%, right? So how much it was there? 33% with OSA. And if we are going with 4+1 architecture, plus 25%. Means if my original data is 100 GB, then here it will go 150 GB. Here it will go 125 GB. Here it will go 133 GB. Okay. So still it is better, like within 3-node configuration. If I would go, if I'll compare it with the FTT1, RAID 1, how much? With 100 GB? 200 GB, na?
200 GB, yes, sir.
Right? But if we'll
Yes.
go with 2+1, RAID 1 FTT1, still I'm getting the efficiency of 50 GB.
50%.
Right? 4+1 architecture, you are getting the more, like if we'll go with here RAID 1 again, you will compare it, you will get more efficiency. Okay, this was my vSAN fixed with 3+1. That was in OSA architecture. So this is something even I need to cross check. Is still with ESA, this 3+1 is available or not? What slide is sensing? I don't think so. This is available because it's a specified here 2+1 and 4+1 architecture, whereas in OSA it was 3+1. But ideally they should give this option also available if in case customer want to leverage this 3+1 architecture still, right? We good? Banu, are we fine?
So Banu said BRB. He'll back in. Someone came. He mentioned in the group chat.
Okay. Oh, recording is in progress. That's fine at all.
Yeah.
Okay. When he left?
12:06, right?
Okay, so this is the one.
3 minutes back, sir.
Okay. Well, this is the actual layout for the RAID 5 FTT1 that you are talking about component. Like
Yes,
per flow, PP. Why? Because it will split into 2. Same way for the capacity, it will split further into 2. Okay. Got it?
Yes, sir.
So it is something like that. Under RAID 5, it is just applying kind of RAID 0. Why I'm saying why it is RAID 0? It is showing RAID 0. If we still you don't apply. Reason is being these components are split. Yeah,
Typing of, yeah.
correct.
It is
The
typing the
underline
data.
is
Yes.
the RAID 0, right?
Correct.
Because these are not this is a kind of spanned volume, na? Probably you have seen in Windows Server.
Correct. Yes, sir.
Like a
We
spanned
have all SQL the spanned volumes. Yes, sir.
right. So this is something like that. My component are further my I would say stripe. The stripe is further spanned or expanded to the multiple nodes, right? So that's what.
Sir, we have some drawback in RAID 0, sir. It's because typing of data means if one step or one disk goes, that data will be
No, that's fine.
difficult to
So
retrieve.
you are right. See, underline it's a RAID 0, but on the top of it, if you will see between C1 and C2, there is a redundancy, right?
They have mirroring copy. Yes, sir. Yes, sir.
Correct. Exactly, it is kind of the combination of RAID 5 and RAID 0.
RAID 0. Yes, sir.
Everywhere they have make as RAID 0 as underline, but on the top we are using kind of this,
RAID 5.
right? Like earlier it was RAID 1 on the top. So not direct redundancy between this and this, but there is a redundancy between this,
And this.
and this.
Yes, sir. Got
Got
it,
it?
sir.
So it is showing here the 2 plus 1.
Banu is back, sir.
Okay, all right. C1, C2, and the kind of C3 it is showing, but ideally it could be kind of your parity, right? So
Correct,
Banu,
sir.
once you were there, where you left?
So I was at that the RAID 1 FTT one concept that you were telling for C3s.
The
Before this,
underlying kind of that.
before
Okay.
this one, sir.
Okay. Okay.
Here I was there. Yes.
All right. So again, the same thing we were discussing about the data writing mechanism here, even
Okay.
with backend, how it's happened. Like in 2 plus 1 architecture, it is data parity, then parity, it's dynamic. But in 4 plus 1 architecture, it is 4 data plus 1 parity, right? For each strand. While in OSA architecture, it was 3 plus 1, 3 data, 1 parity, 3 data, 1 parity. Okay.
Yeah.
And this slide is further showing the split of kind of the underlying component, like what we read even in previous slide also. Any kind of FTT, either RAID 5 and RAID 6, at the underline, it will go as kind of RAID 0 and it will split into 2 components, right?
Okay. Yeah.
So again, what this slide is showing. So like in earlier, we have seen like where we have applied the RAID 1, this C1 was having the 3 component as an underline, right? But
Yes.
as per the policy, if I'll go back again, this slide, RAID 5 or RAID 6 have 2 child component, right?
Yep.
For it, especially for the capacity. But if in case like perf, it is 2 child. In RAID 6, you will get little bit different. 3 child for the perf, okay? But it's still 2 child for the capacity. So that's what this slide is describing here. If we are going to write data, the perf lag will be written like that, kind of a single per flag component, and it will further divide into 2. This C1 will further divide it into CC. Okay. So what we are talking about, ideally it is not purely RAID 5. It is a kind of RAID 5 plus RAID 0 at the underlying. Okay. First, my data will go in a RAID 5 manner, but under this component will further split into the kind of RAID 0 fashion. It will equally divide it into 2 places. Okay. So it's an example of RAID 6 FTT2, 4 plus 2 manner. So what we read in RAID 6 FTT2, how my per flag will return? It will have the 3 child. Okay. It will have 3 child, and my capacity lag will have the 2 child, right? These are the 2 child, and those will be split
Yes,
across
sir.
the multiple nodes, right? Again,
Yes,
I will
sir.
repeat my word. There is no redundancy between this child and this child. Okay. So this is just a kind of, if I'm writing this, if my C1 is 10 MB, then 5 MB is here, 5 MB is here, right? So kind of redundancy I'm getting here on this level, like kind of D, P, okay, like that way. So again, it's a data writing mechanism here. We are going with the 4 plus 2. So it could be like data, parity, data, parity, kind of that, okay? And this is my per flag here, okay? So per flag is kind of my temporary data, okay? That will be further moving to my capacity tier. So it is just an comparison of that. If we'll do RAID 0, FTT 0, we can apply with one host also. That is also fine, 100 GB. We'll compare it with the RAID 1, FTT 1, 3 hosts you required minimum. And what is the consumption? 200 GB, right? Because third one is witness. Then RAID 1, FTT2, 5, 300 GB your consumption. RAID 1, FTT3, 7 host minimum, 400 GB will your consumption. We'll compare with the
Right.
eraser coding here, 2 plus 1, 4 plus 1, because it is my ESA. No 3 plus 1 is available here. Okay, 3 host, 50% more consumption, 5 host, only 25%, RAID 6, 4 plus 2, 150 GB. But here the difference is I am getting the two failure. I can tolerate two simultaneous failure, right? But again, it's a minimum one. What is the best practice would say? We should have 2 plus 1 plus 1 as an spare. Same way 4 plus 1 plus 1 as an spare. Plus 1 I'm just writing for the parity purpose, right? Plus 1 for hot spare, kind of that. And 4 plus 2, 4 data plus 2 parity. The best practice say we should have 2, because as an spare, reason is being, if we can tolerate 2 node failure at a time, that is fine. But to rebuild the data for these 2 nodes, we should have the additional 2 spare nodes available. Correct? So choosing the vSAN ESA policy, again, it's the same way, just to creating the policy and applying that, okay, on the environment. So yeah, that lab is access, deploy VMs, verify VM object and component placement. Then definitely just apply some policies, change those policies, okay, and see the impact on kind of your environment, what's happened here. So that's what we have covered here. ESA supported storage policies and identifying the different type of storage policies, right? So the three things what we have observed here is, the first one is the data writing mechanism, okay, and the difference is the capacity lag and perf lag. So any write data length will happen on the perf lag first. After full stripe of data is received, then it will push to capacity lag, right? So kind of, not exactly, kind of it's working my cache tier here. Then once data will receive, then it will return to my capacity tier. Correct? That's kind of that. So again, we have different set of policies we can define for perf lag and the capacity lag. How data being written in the perf lag? Like if I'll apply RAID 0 FTT 0, my one child object only of perf lag, my perf lag will have only one child object. Kind of, this is my perf lag. It will have only one child. If I'll write something for perf lag RAID 1 FTT 1, it means that perf lag will have two child object, right? And if I'm writing RAID 5 FTT1, again two child object. If I'm writing RAID 6 FTT2, then my perf lag will have further split into 3 component. Okay. Same way, if we'll compare with the capacity tier, this is for an example, my RAID 0. So
my understanding is becoming a little stronger in this, but I think if when we do it in labs, how the component would sit up, I'll be able to probably remember
Definitely.
it accordingly.
Yes.
Sorry.
Right. Yeah, 100% agree with you. So with RAID 0 and RAID 1, it is saying 3 child. It means that if I am writing some data in FTT 0 RAID 0, sorry. So it will go kind of C1 will split into 3 components further. Okay. Same way if I'm writing RAID 1. So RAID 1 means is C1 plus C2. And it will further, my C1, C2 will further, each will split into 3 child component, right? That's what it is saying. Within RAID 5 and RAID 6, if my capacity tier, my capacity will be divided into two child component. So any kind of C1, C2, like C3, whatever I'm writing, each will split into two child component in case of it is RAID 5 or RAID 6. So within these child component, there is no redundancy. The child component in a write is a manner of kind of RAID 0 manner, right? That's what. So definitely, once you'll apply the policy, we'll be able to see where my parent component are being placed and where are my child component have been placed. Okay. So like from theory perspective, that's it from this session. So I'm stopping this recording. Definitely will be covering the labs part also. Don't worry about it.